All right, so just for a couple of additional exercises for your information and for your homework, think about this function here. F of xy is equal to x to the fourth minus y to the fourth quantity divided by the quantity x squared plus y squared. I want you to find the limit of this function as xy approaches 0, 0, that's question number 1, 1, 1, question number 2, and then question number 3 is as it approaches 1, 0. Okay, and then the next question is find the limit, find the line of discontinuity. So that line of discontinuity is the set of all points where the function is discontinuous for this function, the natural log of the absolute value of x squared y. And then the same for this last question, x squared minus y squared all over x plus y, right? You may want to pause and then try to do these problems. And when you think you have the answers, you can come back and confirm your answers. All right, so for this one, right, the idea is this. Just try to do whatever you can to simplify this. All right, so you have x to the fourth minus y to the fourth, x squared minus y squared. So this is, and you can, I mean, I hope you have recognized this to be the difference of two squares. Actually, both of these, right? The top can be factored as x squared plus y squared. By the way, factorization is one of the key things that you will need in as you do your assignment for this section, section 4.2. Okay, so maybe you can take the dust off of the old algebra book and review some of your formulas for factorization. All right, so x fourth minus y fourth can be written as x squared plus y squared and x squared minus y squared. The denominator is exactly the second factor, so you can cancel. This is actually the same function, and now be careful here. I'm going to say this, but wait until you hear the last part of the sentence. This function f of xy is exactly the same function as x squared plus y squared as long as x squared is not equal to y squared. Now, why do I say that? Because if you have that, if they are equal to each other, the function is not defined, so that is not equal to this, okay? But as long as x squared is not equal to y squared, then this function is identical to the function x squared plus y squared. So with that, question 1 is actually easy, okay? Well, by the way, what is these exception lines, you know, the exception points, where this just means that y is equal to plus or minus x. So try to avoid this line and that line of slope 1 and line of slope -1 meeting at the origin. As long as you stay away from these points, which are not in the domain of this function, then this function here is exactly the same as x squared plus y squared. And that gives you a key. Okay? If you approach this from this way or this way, it'll be just like approaching it this way. So what does it approach, right? So as xy approaches 0, 0, guess what? X squared plus y squared approaches 0 squared plus 0 squared. Okay, so this is your limit. Now you may say, well, how come what happens if I approach it this way or this way or this way? Remember, you can't do that, okay? Because you can't approach a limit, you can't approach a function. You can't walk along a path of a function if that path is not in the domain of the function, all right? So you are not allowed to walk along these paths like x is equal to y or x is equal to -y. But regardless, if you continue to approach 0, 0 from any direction defined, then x squared plus y squared is what the function is. So this will approach 0. Okay, and in the same way, you can think of Q2. Okay, so what's Q2? As y approaches 0, 0, what does it approach? It's going to approach 1 squared plus 1 squared, which is basically 2. Okay, and so how do you know that? Oh, by the way, when you try to plug in 0 here and 0 here, you know this is an indeterminate form. Okay, so you would have to use some clever thing like this cancellation. Right? Same thing here. For 1, 1, if you try to plug in 1 here, 1 here, 1 here, 1 here, you get 0 over 0. So you can't. And so you would have to do some sort of cancellation after factorization. And again, understanding that this f is equal to this, okay, except for these exceptional points, you plug in 1 and 1 for x and x, you get 2. For Q3, you can simply plug in 1 and 0. If you plug in 1 for x and 0 for y, you just get 1 over 1. This one is approaching 1, 1. This is approaching 1, 0. You can plug in x is equal to 1 and y is equal to 0, and that will be just simply 1. Okay, so that's a pretty easy question here. Okay, and by the way, you can also plug that same thing in here too, right? If x is 1 and y is 0, the answer is going to be 1. All right, now the line of discontinuity, basically, this is a phrase that you will see in your assignment. It's basically the set of all points where the function is discontinuous. And in this case, it turns out to be a line or lines of discontinuity. Okay, so where is this undefined? So this function, now, because of the absolute value, this is almost always defined, okay? Because, I mean, x squared y could be negative, but if x squared y is negative, this absolute value sign will make it positive, and the natural log is defined here. So this is undefined, and therefore, this continuous. Remember, the log function is continuous. What did I say? Log function, including the natural log, ln, is continuous wherever it is defined. So the only discontinuity this has is where this is not defined. So ln of this is undefined, or of course, therefore, discontinuous, if and only if x squared y is equal to 0. Okay, so where is that? That's x, y is equal to 0, right? And so this means either x is 0 or y is 0. So in this case, the line of discontinuity will be 2 lines where y is equal to 0 and x is equal to 0. These are the 2 lines of discontinuity because these are the points. These are the set of all points where the function is undefined and therefore is discontinuous. If you pick any other points off of these coordinate axes, regardless of what they are, x squared y is going to be either positive or negative, and the absolute value of that is positive, and the natural log is defined and is continuous, okay? So these are the only points. All right, so what am I supposed to do with this one here? The same thing, find the line of discontinuity. What you are assuming here is that x and y could be anything, or can it be anything? Again, rewrite this as x plus y, x minus y, all over x plus y. You can cancel, and you understand that this function f is exactly the same function as x minus y, as long as x plus y is non-zero. Okay, so this means y cannot be equal to negative x. All right, so in terms of the line or lines of discontinuity, you avoid this line. Oops, that's, y is equal to negative x. And this is the set of all points where f is not defined, which makes them the points of discontinuity. Remember, to be continuous, you have to have the value of the function. The function has to be defined at that point. So these are the sets of points where it's not defined and therefore it's not continuous. How do you know it's continuous everywhere else? Well, because it's a polynomial over polynomial and a rational function, therefore. And so a rational function is continuous wherever it's defined. So the only points where this is undefined and only points where this is discontinuous is on this line. So this is called the line of discontinuity. Okay, I think you are ready to do all your homework problems now. Hello, so this is a continuous function. What you're seeing is a function that seems to be continuous everywhere. There is no hole or you know, asymptotes or any kind of gap or anything. And so what you're seeing is a continuous surface, which is a function f of xy, where the limit is always equal to the value of the function. All right, so with that, I will conclude section 2. And when you get into section 3, we will be talking about derivatives, partial derivatives, in fact. And so chapters up, you know, chapter 4 is actually a pretty long chapter. It has 8 sections. And so we'll start taking derivatives in different ways because we are in a multi-variable functions. And so you can't wait, right? Okay, so this concludes to 4.2, and I hope you have a great day and a great week until we see each other in section 4.3. Take care.